Today we're going to look at C and D. Then we're going to put it all together in your equation. All right. What did A give us? Vertical stretch, and then which was just the amplitude. It also gave us a reflection, but that didn't affect our vertical stretch at all, which didn't affect our amplitude. It just caused it to flip up or down. What did the B do? It was a horizontal stretch, and it helped us get the what of the graph? The period. The period of each sine and cosine graph is what? 2 pi or 360 degrees. And our horizontal stretch will either make it happen longer or shorter. Correct? We went over those things. So today we're going to look at adding more to it. And then we're going to give the hardest part, which is graphs. And then you have to come up with the equation of the graph. Okay? So we're going to do this. Yeah. So this is the first one. So we have just the 3. Is it with the x or is it at the back? It's at the back, so it's the? Yeah, it's vertical displacement. Vertical displacement. Three up. Or you could say 3 units up, it's still fine. Now, what I need you to do is in your calculator type in sine x and y1 and sine x plus 3. Make sure you close the bracket on the x in y2. So, we have sine x, and then we have sine x plus 3. Now, if we put it in the bracket, it's going to move it 3 to the left. Is that what we want it to do? No, because there's no bracket in the equation, so we have to close it. So what ends up happening, I'm going to go 2 degree mode. Zoom, trig. Okay. So what did it do to it? It moved it, vertically displaced it 3 up. Now, what has changed? The x-intercepts. The y-intercept. Did the range change? Yeah, because it was from -1 to 1. It's now from 2 to 4. Did the amplitude change? No. Because what changes the amplitude? My vertical stretch. And is there one? No. It just moves it up or down, right? Amplitude's half the distance from the min to the max. Well, that's not going to change unless my amplitude changes. Did the period change? No, because what changes the period? And was there a horizontal stretch?
No.
No. All right. So this is something to note. What we just found was the midline. So on all the previous equations we had y equal to 0. We had a plus 0 at the back. That was yet last time, right? So all of them were symmetrical about the x-axis, which happens when your d value is 0. In this case, my d is what? 3. So it's actually the line that cuts the graph in half. That's actually kind of straight. Good job, Lepp. Okay. Y equals 3 would be the line that cuts the graph in half. Do you see that? Okay. What was the amplitude of this equation? It was y equals sine x plus 3. So what's in front of here is a 1. So if I don't have an amplitude, it's 1. If I don't have a horizontal stretch, it's a 1. If I don't have a horizontal translation, it's a 0 phase shift. And if I don't have a horizontal or vertical displacement, it's 0, right? These are 1s, these would be 0s if there's nothing there. Now, my amplitude is 1. We agree? Because of the vertical stretch, which is 1. So I know my amplitude is 1. So if I actually count down 1 and up 1, where do they meet at? This is the midline. So your d value is actually your midline. It's the line that cuts the graph in half horizontally. Or vertically, sorry. It's a horizontal line that cuts the graph in half vertically. So a midline is 3. Do we see that? So how could I get my range from this equation without typing it into my calculator? Anyone have any ideas? Well,
If you know your midline and your amplitude, then you can figure it out.
right. How?
Just take your midline, add your amplitude.
Yeah, exactly. He said, if you know your midline and you know your amplitude, you can take your midline and add your amplitude and you get your max. You can take your midline, subtract your amplitude, and get your min. If I had one of those stamps that I'm buying, you'd get one right now. You win. No one ever gave me that example. All right. So how could you obtain the range without the graph? Your maximum. He was the fastest hand up. He won. All right. He won today. So the maximum is the what? The midline, which is the what from the equation? Okay, the midline is the what from the equation? Which letter is the midline from the equation? Let's try and reword it. D. Woohoo! There we go. I realized the question was not getting the answer I wanted, so restate. Okay, so midline is D. So we go the midline, which is D, plus the what? Amplitude, right? And then the minimum, if we took the midline, which is the D value, and we subtracted the amplitude, we'd get the min, and then we'd have our range, wouldn't we? Okay. So, in this case, I'm just going to do it over here because I used a proof. Nah, I'm going to do it. So the maximum in this case would be the D, which is 3, plus the amplitude, which is 1, so I get 4. And my minimum would be D minus the amplitude, which equals 2. Can I swap them? Can I do amplitude and D? Can I flip-flop them and still get the right answers? No, it has to be midline plus amplitude to get me to max. Midline minus amplitude to get me to min. So I'm going to write my range up here. So my range would be y such that my minimum, which is 2, is less than or equal to y, is less than or equal to my max, y-e-r. Or if they give you interval notation, you should throw a party because it's just 2 to 4 square brackets. And we have to circle what changed. What changed? Did the amplitude change? No. Did the range change? Yeah. Did the period change? No. Did the domain change? Hint, it's not going to because it's a XER. So no matter what I squish, push, it keeps going. X-intercepts, did they change? Y-intercept? Okay, what's the period of the graph? It's 2 pi or 360 degrees because they'd have to specify. Because the only way we can tell if it's in radians or degrees is if there's actually a C value. Because the C value has to be in degrees or the C value has to be in radians. And because I don't have one, they'd have to ask me for what period and what in radians or degrees. They'd have to specify. My mapping, what's it? X, Y. X comma Y plus 3, yeah. Does the coast make any difference? No, because the coast graph is just a what shift? Remember? It's a horizontal phase shift of how much, do you remember? Yeah, 90. The horizontal phase shift of 90 degrees or pi over 2, right? When we moved one the other way, we got them on top of each other, so the same thing. So I want you to do, for here, I want you to do the transformations and the mapping, which has changed, what's the range, what's the period. For 2 and for 3. Try them out. Actually, sorry, for 2. We'll do 3. So this is a vertical displacement. Okay. Vertical displacement 2, down. What's my mapping? X, Y becomes? Did the amplitude change? Range. Period. Domain. X-intercept. Y-intercept. What's the range? So I do maximum. What's my D? -2 plus my amplitude, which is 1. So it's going to be at -1. My minimum is -2 minus 1, so it's going to be at, does that make sense? -3 to -1 is a distance of 2, amplitude is 1. Yeah, sounds good. Would the middle of that be at -2? Between -3 and -1? Yes, so you actually can visualize it, right, without typing it in. So my range is going to be y such that Negative 3 is less than or equal to y is less than or equal to negative 1, yer. Make sure you do minimum to maximum. Nothing sadder than you do all the work and flop them on the test. Just sad. And then negative 3, negative 1. What's the period of this one? 2 pi or? Because there's no c value. And there's no, actually, horizontal. Yeah. Horizontal stretch. The b value. No, b. What's the difference with this one? It has a vertical stretch, which was from last lesson, right? And the vertical stretch does what? It stretches it. It amplitude, yes. Okay? It stretches it so it makes your amplitude different. Shh. And what's this? Which is also known as the, rhymes with midline. Midline, good job. Okay, so it's the midline. I went for that last time. It was a real shot in the dark. No one got it. So vertical stretch of 3, and then we have a vertical displacement of 2. It's moving it up 2 and it's stretching it taller, correct? So think about it. Moves it. It stretches it first, though, right? Because we have to do stretches and reflections first, then translations. So it makes it taller. Shoop, stretches it by 3, so now it's 6 apart, correct? And then it goes up 2. So it's around here. Visualizing. Good visualizing. Okay, so we have, will that affect my amplitude? Yeah. Will that affect my range? Yeah. Will it affect my period? No, because there's no b. What about the domain? No. What about the x-intercepts? Yeah, because it shoves them up, correct? What about the y-intercept? Yeah. What's the only thing that won't affect? What's the only thing that won't affect my y-intercept? A horizontal stretch, because my y-intercept has x's of 0, so it has to be multiplied, or a reflection in the y-axis, correct? And x-intercepts are only not affected when there's a vertical stretch or a reflection in the x-axis, because your y's are 0. All right, so we have a vertical stretch. Yeah, the only thing that changes is vertical displacement and horizontal phase shift. Vertical stretch by a factor of 3. Good answer. About the x-axis. And a vertical displacement 3 up. What's my mapping? That's a 2. I have no idea what you're talking about. xy becomes x3y plus 2. That's obviously a 2. Yeah. Okay. How do I get my range? Does not change. My maximum is still my midline plus my amplitude, and my midline minus my amplitude gets my min. So the maximum is the midline plus the amplitude, so it's at 5. And then my minimum, I have a midline at 2, and then I subtract 3 down from it, and now I'm at negative 1. What's the distance between those? Wow, that was aggressive. 6. Something happened there. And then what's in the middle of that? 2, right? My midline. Yes, both of you answered correctly. Midline and 2 are in the middle, right? So I know I'm good. Now my range is going to be y such that y is negative 1 is less than or equal to y. Is less than. I always show work, because then if I make it oopsie, I have some work to get possible part marks from. You can do as you wish. And the period of this one, did it change? Because there's no what? Horizontal stretch. So 2 pi or 316 degrees. Okay, you're doing number 4. Okay, we have a vertical stretch. Okay. Vertical stretch by a factor of 2 about the, and it's not negative because the negative is actually a what? Reflection. And the 3 is a what? Vertical displacement three down. And so what we're going to do is we're going to stretch it taller. It's going to flip, but that just means that the maxes will become mins and the mins will become maxes. So it doesn't change your height or anything, right? It just changes the look of the graph. It doesn't change any of the other thing. And then it's moved 3 down. So did my amplitude change? The range, period, domain, x-intercept, y-intercept. So the minimum, oops, I need to do mapping. So it's going to be xy becomes negative, becomes x, comma, negative 2y minus 3. Nothing happens to the x because the x is literally in a bracket by itself, right? So nothing should happen to the x in mapping. Now my range, the minimum, or the maximum, let's say, is d, which is negative 3, plus my amplitude, which is actually 2, not negative 2. So it's going to be at negative 1. And the minimum is negative 3 minus 2, which is at negative 5. This entire graph is below the x-axis, which makes sense because you stretched it by 2, but then you shoved the whole thing 3 down, right? Now, it has a distance between it of 4, which is an amplitude of 2, 2 and 2. It has a midline at negative 3, which would fall directly between negative 1 and negative 5. So it sounds like it's good. So you're going to have negative 5 is less than or equal to y is less than or equal to negative 1, y-er. And then negative 5 and negative 1. The period is still 2 pi or 360 degrees because there is no b value. Flip over. What happened now? You get a horizontal phase shift, and for 6 you're going to get a horizontal stretch. Is it taken out? No, so make sure you take it out. Now, what's my C in? What's my C in? So my period's going to have to be in radians. What's this one in? So the period's going to have to be in degrees. Try these out. 5, 6, 7, go. So this one, what is our B value? Our A is negative 1/3. Our B is, what's our B? 1. Our C is pi over 2. And our D is plus 2. So what's your axis in? It's in radians because your C value is in radians. All right, so what do we have? We have a vertical stretch by a factor of 1/3 about the x-axis. We have a reflection in the x-axis. We have a horizontal phase shift. Yep. Pi over 2 to the right. And a vertical displacement. Shh. You guys, you should be quiet because just so you know, and I'm going to remind you, my mic picks up everything. Vertical displacement 2 up. So xy becomes x, and what do I have to do to it? Plus pi over 2, yeah. It's the only thing that's in the bracket with the x, so it's the only thing that's going to happen to my mapping. And then I'm going to multiply my y's by negative 1/3 and add 2. So not only has this graph actually shrunk vertically, correct, by 1/3, so it's shrunk, and it's flipped, but that just makes it look different, right? The min become max, the max become mins, but it doesn't change my domain range, any of that stuff. Then it's moved 2 up, so it's shrunk, moved 2 up, and pi over 2 to the right, right? Every phase. So, did my amplitude change? Yes, it was 1. It's now 1/3. Did my range change? Yes, if my amplitude changes, my range changes. If vertically displacement happens, my range changes. The only time my range doesn't change is if all I have is a reflection in the x. Did the period change? No, because b is 1. Did the domain change? No. X-intercepts and y-intercepts will always change the moment you have any type of translation. So like a vertical displacement or a horizontal phase shift. Any of those will take your x-intercepts and move them off. What's the range? Well, my maximum is my midline. My midline in this case is 2, plus my amplitude, which is a third. So I get 2 plus a third, so it's going to be 6 over 3 plus 1 over 3. So 7 over 3. And then my minimum is going to be 2 minus a third, which is 6 over 3 minus 1 over 3, which is 5 over 3. So my range is going to be y such that 5 thirds is less than or equal to y is less than or equal to 7 thirds y-er. Don't put a terminating decimal. These don't terminate. So if you put a rounded decimal for them, you wouldn't be right. Unless it asked you for a rounded decimal. And what's the period for these ones? 2 pi. 360 isn't an option because it was in radian. Okay, this one, I have to remember to take the half out first. So I'm going to get y equals, if you want, you can put a 1 in front. Sine 1/2 theta. When I divide by a half, it's like multiplying by 2, so I get 30. And if you want to, you can put a plus 0 at the back. Like, you can fill in A, B, C, and D. If A doesn't exist, it's a 1. If B doesn't exist, it's a 1. If C doesn't exist, it's a 0. If D doesn't exist, it's a 0. So you can fill them in if you want, if it helps you. So the only thing we have here is a horizontal stretch. By a factor of 2. About the y-axis. And a horizontal phase shift. $30 right. Yeah. Yeah. Okay, did the amplitude change? No, because my amplitude is 1. Did the range change? No, because a midline 0 up 1, midline 0 down 1 gets me negative 1, 1, which means no change. The period? Yep, it's going to double. The domain won't change. It's XER, right? It just keeps going on for life, so nothing will affect it. Like, even if you stretch it, it'll just still go up forever. X-intercepts? They're going to change because we're going to move, not only are we going to multiply all of our x's by 2, we're going to also move them 30 to the right, so they're going to change. And my y-intercept changes only because I multiply my x's by 2, which does nothing, but then I move them 30 to the right, so I just shift it right off the y-intercept, right? So it's going to change. My mapping is going to be xy becomes 2x plus 30 degrees. Y. Don't forget the degree symbol, or it's a radian. What's my range? Well, my maximum is d, which is 0, plus my amplitude, which is 1, so 1. My minimum is d minus 0, so 0 minus 1, which is negative 1. So negative 1 is less than or equal to y is less than or equal to 1, y-er. And the period, we have to do 360 degrees divided by absolute value of b, if we want to use the formula. So it's 360 divided by a half, which is actually 720 degrees. So you can use the formula, or you can say, hey, it's normally 360. I'm now stretching it by 2. So instead of it being 360, it's now going to happen every 720, right? But either way works, formula or just multiplying it by the horizontal stretch. 7, I can add a 0 to the back if I want to know 1 here. Once again, my range isn't going to change, right? My midline 0, my amplitude's 1. I'm going to go over here. The amplitude doesn't change, the range doesn't change, the period is going to change. and the x and y intercepts. Because I have a horizontal stretch by a factor of 1/3 above the y-axis. And a horizontal phase shift pi over 2 right. So my mapping will be xy becomes 1/3 x plus pi over 2 comma y. My range is going to be y such that -1 is less than or equal to y. It didn't change. Is this period shrinking or widening? Why? Because it's 1/3, horizontal stretch of 1/3. Yeah, you see? Yeah. So, we can go 2 pi divided by the absolute value of 1/3, which is actually, try again, left, try again, absolute value 3, which is just 2 pi over 3. Or I can use 2 pi and multiply it by the horizontal stretch, which is 1/3, and I'll still get 2 pi over 3. Same answer, right? What's wrong with my shoulder? Okay. In general, for y equals a sine b theta plus c plus d, or y equals a cos b theta plus c plus d, a represents the what? Vertical stretch or the amplitude. B represents the period of the graph can be found by using B in the formula P equals 2 pi over the absolute value of B, or P equals 360 degrees. Or you can just take the period and multiply it by the horizontal stretch. C represents the what? Horizontal phase shift. The equation must be in the form y equals a sine b theta minus c plus d. The b has to be taken out, just like always. Nothing changed with transformations there. Your horizontal stretch isn't taken out. Your horizontal phase shift is going to be wrong, just like it was in transformations. It doesn't change, doesn't matter. The only thing that changes is the two words, horizontal phase shift and vertical displacement. D represents the what? Vertical displacement. The range can be found by, yeah, so the max equals the midline plus amplitude, or D plus absolute value of A, right? And the minimum is the midline minus the amplitude. So if the min is less than or equal to y is less than or equal to the max YER, or square bracket min comma max. In that notation. And we're going to flip over. We're actually going to go past this graph and go here. You try example 3 and example 4. See how you do. Killing me. When I give you the words amplitude, period, horizontal phase shift, vertical displacement, the only one that is not going to go directly in is the period. Correct? Amplitude will go in for A, horizontal phase shift will go in for C, vertical displacement will go in for D, but your B value is not your period. So the period should never just go right in. So that pi for period should not be B. They will put that as B every single time, or the flip of it, 1 over B. Those will be your oopsies. They'll put that because that's what people put. But for us, we're going to go y equals the amplitude, which is 2, and then we go sine, and then we need to get the B. Well, if the period is pi, we know it's shrunk by a half, which means this is going to be 2. But if that is too much for your brain to go for, and that's fine, it can be. I wouldn't even want to go that route because my brain in high school would not want to do that. I can use the formula, which will do it correctly every single time. It's pi, so I'm just going to use 2 pi divided by the period, correct? So it's going to be 2 pi divided by pi, which is 2. No thinking about stretching, flipping, nothing like that. It's 2. So I go in and B is 2, so I put a 2, right? I don't have to use a lot of brain matter that way, and I can't make, it's good to check. So even if you do it with the horizontal stretch, I would check it with the equation, with the formula. And then we have x minus, but it's to the left, so it's plus pi over 3. And then a vertical displacement 1 down, minus 1. So the period of this one is 6 pi. So B is going to be 2 pi divided by 6 pi. So it's going to be a third, which makes sense because a third is a horizontal stretch of 3. And I went from 2 pi to 6 pi, so I multiplied by 3. So you should be able to double check yourself. So we're going to get y equals a quarter sine a third. Not flipping it because B is a third. So I take this and put it for B. X plus pi because it's to the left. And then 2 up plus 2. Now you have to watch. Sometimes they'll give the equation without the brackets in here, so they'll actually just distribute that in, and that's their equation. So you watch yourself, because it can be that way too. Like they could give the answer of 1/3 x plus pi over 3, and they're not wrong. Correct? They could distribute it. You always start it out though, and then you distribute in if they go that route. Amplitude of 4. Y equals 4. The period's 540. I don't want to use my brain matter, so I'm going to go 360 degrees divided by the period, which is 540. And what do I get? What's 360 divided by 540? Way less brain matter you needed when using formula, correct? I go this route. So you can check it with your actual horizontal stretch, but sometimes it's harder. So radian measure is actually easier to do your B value with, I think. Okay. Sine 2/3. Bracket x, phase shift of 60, right? So minus 60 degrees. Don't forget your degree symbol, or it's in radians. And then 3 down. So that was if I gave you amplitude, period, phase shift, vertical displacement. This one is if I give you transformations. So it's cos graph. It says vertical stretch by a factor of 1/3. So I'm going to get 1/3 in front. Because the words and mapping are the same. But remember that horizontal stretch and stuff goes in backwards. Right? And then cos, horizontal stretch by a factor of 2, so I'm going to get a half. Horizontal phase shift 30 right, so I'm going to get x minus 30 degrees. Vertical displacement 5 down. And you should appreciate these ones because they're not like a transformed graph you have to transform. They're just a basic graph, right? You just plug your stuff in. That's way easier than if they gave you like a cos graph that was transformed first and then made you transform it, which they can do. Vertical stretch by a factor of 4 about the x-axis. Cos. Horizontal stretch by a factor of 1/4, so 4. It flips. Horizontal phase shift, so x plus pi over 2. And then plus 3. This is your actual homework. Because you need to practice these. You need to be able to do them backwards, forwards, left, right, because tomorrow we are going to give graphs, and you have to come up with all 4 possible equations. So there's a positive sine, positive cos, and negative cos. So the only thing that changes is C. It's not that bad. Your A's and your B's and your D's will always be the same. It's just your C's that are different. So here it says, number 1, A, B, D, E, or 1, A, goodness, oh my gosh. 1, B, D, E, just sketch D. 2, B, D, E, just sketch D. So I just want you to be able to sketch a couple. I don't want you to sketch the whole book. So anywhere else it says sketch, don't do it. And just so you know, 3 to 5, I think, are all matching. So you just have to match the graph with the equation. So a lot of them, it looks like it's more than it actually is.